Welcome back again to today's session. My name is Dr. Anthony Uwandu-uzoma. So today we are going to look at how to run repeated measure ANOVA using the SPSS. We're going to delve deeper into the concept, some theoretical concept, and then we'll back it up with the practicals. So I've done a previous video on this, and if you have not watched it, I will drop the link in the description on the previous video. So basically, let's look at our data. So our data is organized this way, such that we have an intervention group, and we did 3 interventions. Okay, so the first intervention we did was exercise. The second intervention was people placed on vegan diet, and then the third intervention was people placed on dairy diet. Okay, and then we measured the weights on month 1, month 6, and month 12. Okay, for all the individuals, and then we also measured the mental well-being score, on month 1, month 6, and month 12. So basically, we want to see whether there is any significant effect of our intervention across these different time periods. Okay, so this is how our data should be organized. So this is the data view here, and this is the variable view. Okay, so basically we have just typed in the data in the variable view, the names of the columns. Okay, and then all these variables here, the weights and the mental well-being score, they are all scale, while our intervention group is nominal. That's for the variable view. Then, so this is the data view. So now, before I go deeper, I want to just lay some theoretical foundation. All right. So basically, so when you have such a kind of data set, you are asking basically 3 questions. Question number 1, is there a significant change in the effects of the independent variable on the dependent variables across different time points? Now, what you call that kind of effect is the within subject effects. Okay, whenever you are factoring in time in your analysis, that is you are looking at the within subject effects. Okay, now when you are not concerned about time, you just want to know what are the effects of the independent variable on the dependent variable, regardless of time. That is between subject effects. Okay, and then finally, in repeated measure ANOVA, you are asking, is there a significant interaction between time and the independent variable on the dependent variables? Okay, so you're looking at the time drug interaction, the impact of time drug interaction on the dependent variable. Okay, so this is the kind of this is the nature of the question that you can answer with repeated ANOVA. And with this kind of question, repeated ANOVA is part of the general linear model. Okay, so here there are some important tips that you need to know. Okay, now the first thing is to check for sphericity assumption, okay, and apply the corrections where necessary. So basically, sphericity means we are assuming that the variances of the differences between all the pairs at the different time points are equal. Okay, so, and that is one of the assumptions uh, of repeated measure ANOVA. So the null hypothesis for Murchie's test of sphericity is that when this Murchie test of sphericity is significant, less than 0.05, it means that the variances of the differences between all the pairs at different time points are not equal. So that means the assumption of repeated measure ANOVA is violated. Okay, so in that case, you're going to use another test that is called the greenhouse geyser test. When this when this Murchie's test of sphericity is significant, that means that means that the requirement of one of the assumptions of repeated measure ANOVA is violated. So you need to use the greenhouse geyser effect. Okay. So, but then when we get into the practicals, we'll demonstrate this. Okay. So, and then another thing that we need to know is that when the greenhouse geyser test, when the p-value is less than 0.75, so it means that you can safely interpret your findings using the values from the greenhouse geyser test. Okay, but if it is between 0.75, if the p-value is between 0.75 and 1, then you're going to use the Hunfeld's adjustment test. All right. So now I want to stress here at this point that all these adjustments are necessary when you are looking at the univariate test. This is because the multivariate tests are robust and they are still valid even when the sphericity is not assumed. So I'm going to show you a demonstration in the SPSS. So basically, in summary, what I'm saying is this, that when you are interpreting the multivariate output from SPSS, the multivariate test is very robust, so it can accommodate the requirement for sphericity being violated. Okay, but when you are interpreting the univariate test or the within group effects test, then you have to make sure that your sphericity requirements are not violated, or if it is violated, then you utilize the greenhouse geyser adjustment or the Hunfeld's adjustment. Okay, so that is that. And then one more thing, we also look at the partial eta square, that is the effect size. Okay, so alongside the p values, and you follow the rule of thumbs. For a small effect size, the range is up to 0.01. Okay, if it is between 0.01 up to, sorry, for the small effect size is between 0.01 to 0.0 below 0.06. Okay, that is small effect size for the partial eta square. While from 0.06 to less than 0.14 is medium effect size. Okay, and then from 0.14 and above is a large effect size. So basically, we are saying that if the p-value is significant, we want to know the contribution of each of the variables, how much variation of each of those independent variables can explain the dependent variable. All right. Then the next thing we need to know is the box M test. So this box M test, basically, it helps us to verify that the groups being compared have similar covariance structures. Okay. So we use this test to check if the covariance matrices across multiple groups are equal. Okay. So, however, like we said before, multivariate tests are very robust. Okay. So, if you have an equal or nearly equal number of people in all the groups in your research, and you the ratio, this ratio here of the largest to the smallest, the ratio of the largest to the smallest number in each group is less than 1.5, then even if this box test is violated, it will not affect your research significantly. Okay, so basically, when you have a larger group, then this box M test, even if it's not even if it's not significant, then you don't need to worry about that. Okay, then last thing we need to talk about is the degree of freedoms. How do we actually get it? Okay, so like I said, within subjects, degree of freedom, when you see here the word within, it means we are looking at the impact of time. Okay, we are beginning time. We are looking at the impact of the independent variables on the dependent variables, but then we are considering time. Okay, so how do you calculate the degree of freedom? So if you, let's say, if you measured, if you like in our research here, you see that we measured the weights and the mental well-being score at three different time points, at month 1, month 6, and month 12. So our within subject degree of freedom, okay, will be what? It will be what? 3 minus 1. That will be 2. Okay. And then for the second part of the degree of freedom, the error degree of freedom, how do you calculate it? That is the number of the time points minus 1 times the number of subjects minus 1. So in my research, how many subjects do I have here? I have 69 subjects. Okay, so for my own research, that will be what? 3 times 1 minus 16, sorry, 3 minus 1 multiplied by 69 minus 1. So that will give me the degree of freedom. Okay, so now for the between subjects degree of freedom, so you're looking at the number of levels of your research. Okay, so for my own research here, I have 3 categories: exercise, vegan diet, and diary. So we have 3 groups. So My between groups degree of freedom will be what? 3 minus 1. That will be 2. Okay. If you have two categories, maybe you're comparing two drugs, then that will be 2 minus 1. That will be 1. Okay. Why the error of the degree of freedom, just like we did before. Okay. So the error here will be the number of subjects. The error of the degree of freedom will be number of subjects minus number of groups. Okay. So assuming you have 30 subjects, that will be 30 minus 2. That will be 28. So that is how we get the degree of freedom. So like you see these two numbers here, F2 and 38. So that is how we get them. So this 2 here is representing the degree of freedom, while the 38 is representing the error in the degree of freedom. Okay, so that's how we get it. So it's very important that you know that. Okay. So, and then for the interaction in the degree of freedom, we will have if you have two time points, okay, and two drug types, for example, that will be 2 minus 1 times 2 minus 1. So for my research, I have 3 time points, month 1, 2, 3, and then I have 3 intervention groups. Okay, so my own for the interaction, it will be 3 minus 1 times 3 minus 1. All right. Okay.